All right. Good morning, everyone. My name is Sarah Valdivinos. I'm the manager for postdoc and graduate student professional development here at UCLA in the graduate division. Thank you so much for joining us this morning for the Careers in Imaging and Visualization panel. Before I introduce our moderator, I just wanted to let you know who the co-sponsors for this event are today. CNSI, the UCLA Graduate Division, UCLA Career Center, Strobe and NSF Science and Technology Center, and the David Geffen School of Medicine Office of Postdoctoral Affairs in the Biomedical and Life Sciences. So we'll go ahead and get started, and I'd like to introduce you to our moderator today who will take it off. It's Mike Lowe. He's a Ph.D. candidate here at UCLA in bioengineering.
Hi, good morning, everyone. My name is Mike, and I'm currently a graduate student here at UCLA working on imaging-related projects. So hopefully today, with these very diverse set of panelists, we could get some questions answered about imaging and visualization as a career after your PhDs. So before we get started, I just want to get a sense of what the audience is. So for those of you who are working in the imaging or visualization-related fields, can you raise your hand, please? Yeah, and for those of you who are still unsure whether or not you want to go into industry or stay in academia after graduation, can you raise your hand, please? Yeah, so I think I'm in the same boat as you guys, so I'm still trying to figure out what exactly I want to do after I graduate, so hopefully today we can solve some of those questions. Yeah, so today we have a very diverse set of panelists, and I'll just let them introduce themselves. So for each of the panelists, please explain your educational backgrounds, a very short snippet of what you did for your thesis, if you remember, and then kind of how, and your professional careers now, and how did you get from point A to point B? How did you start your careers in imaging outside of academia?
Do you want the 2-minute, the 5-minute, or the 30-minute?
2 minutes or less. Yeah, so we could start with Scott.
Sure. Hi, good morning, everyone. My name is Scott Singer. I work at Strobe, no relation. It's a different Strobe panel. I did my PhD here at UCLA in the physics department under Professor Chris Regan, graduated in 2012. My thesis, we were studying the thermal emission of carbon nanotubes. So we made the world's smallest light bulb, at least at the time, and heard all the jokes about that. You know, how many physicists to make the world's smallest light bulb. But we basically built a mic.
How many?
Just 3. And so we were correlating color imaging with a microscopy, just standard optical microscopy, and with electron microscopy of it. And towards the end of my time, we started looking at graphene and focused on seeing, you know, what is the spectral emission of, you know, how does it correlate to Planck's law when your objects are smaller than the wavelength of light they're emitting. So after I graduated, I went to work for a subsidiary of Boeing called Spectralab up in Sylmar. They focus on solar cells for space. So I transitioned a lot of the fabrication experience I had from the Nanolab and the ISNC here to the 3.5 processing for space solar cells. And while at Spectralab, I then they also have a group that does infrared cameras and 3D imaging. So I started studying LiDAR and infrared 2D imaging, long wave and mid wave, until I started working for Strobe just for the last year and a half, about where we are using very narrow line width lasers to build an automotive LiDAR. So for anyone unfamiliar with LiDAR, we send out light, measure the time of flight to objects, and use that to build a 3D picture of the world around us. Specifically, we're targeting for self-driving cars, and there's a lot of stuff in the news about that. So it's different imaging than I used to do, but imaging's all around us.
Great. Karen, next.
Hi, good morning. My name's Karen Jiang. I graduated from molecular medical pharmacology in 2013. My thesis was prostate cancer. I'm a biologist, so we use viral vector, adenovirus, and sometimes lentivirus to deliver imaging reporter genes so we can diagnose prostate cancer and metastases. And then after that, I did a 2-year postdoc in urology, also at UCLA. I did some fluorescent imaging using near-infrared and far-red dyes. And then I went to work at ImagineAb. It's a small, not really startup company where we use antibodies and we did PET imaging also in oncology applications. And now I moved to NantBioscience end of last year, and right now we're working on all kinds of different categories of cancer or diabetes or a lot of diseases therapeutics. And for me, my group, we work on animal models, and we set up the model, and sometimes we use imaging as a facilitator to validate the model or to validate the therapeutics. So we support the whole company's development of therapeutics.
Great.
My name is Greg Bearman, and let's see, my degree was 42 years ago, so let me think about it. My degree was in atomic physics, and very briefly, I'm sure you've all heard that there are about 4 or 5 different constants. If they're all a teeny, weeny, tiny bit different, the universe wouldn't exist. Well, I did a measurement of one of those constants called the fine structure constant. And so when I left Brandeis, I moved to JPL. I was at JPL for most of my career. And I think it's worth pointing out that since I left Brandeis, I've done nothing, and I mean nothing, related to the thesis topic. When most of my career has been in, I went to, as a postdoc, I switched and went into what's called low energy molecular collision, so I learned spectroscopy and different kind of photon counting and vacuum technologies. I moved to JPL and worked on population inversion mechanisms for lasers. And then starting about the early 90s, I got interested in biology and medicine. I basically switched, and most of my career has been in biomedical imaging and imaging spectroscopy for biomedical diagnosis. And I had, so I worked a lot with, companies and trying to, what we now call translational research, where you have an idea, but you just don't want to publish papers on it. You want people to use it. I left JPL in 2008. And while I was at JPL, I had a company. I've had several companies since then, and I have another company now that I just started with some colleagues at USC that has new software and algorithms for analyzing this kind of spectral data that I've worked with.
And I'm Robert Hurt. I got my Ph.D. here at UCLA in '93 after realizing I was not cut out to be a plasma physicist, which I started to try to do. I pivoted into astronomy and astrophysics, and I've been sort of spending my career working my way to shorter and shorter wavelengths, I think, in multispectral. I started as a radio astronomer studying gas dynamics in starburst galaxies, and with my first and second postdocs, started getting into shorter wavelengths of light down into the infrared regime. Then basically, towards the end of my first postdoc, I'd actually realized I decided I didn't want to go the academia route. I was trying to find if there was a good position for sort of a good astrophysics staff science position. And so my second postdoc at IPAC was chosen as a science and data center for astronomy, and hoping that would roll over to kind of career jobs, which it did. After doing working on a couple projects then at IPAC, I had developed a reputation of being very good at rendering data for public consumption, both for science and for communications. And so with the launch of NASA's Spitzer Space Telescope, they sort of created a position for me to take over all of our public visualization and communication needs. So I work closely with the JPL media office to produce all of the imagery that we did. We actually have another artist who works on staff now. So my job is basically trying to take the data sets that we're working with across the spectrum, and I've made it all the way into the to the X-ray now. So I think I have a very broad wavelength coverage in my career. And render this for communication and outreach purposes as much as science communication.
Okay, great. So before we start the panel questions, I just want to say that everyone can chime in whenever they want. I want this to be more of a dialogue than just a simple Q&A. Yeah, so after listening to what you guys said about your backgrounds and how you got to your current career, it seems like it's a very big disconnect between what you used to do and what you do now. So I wanted to ask you guys to share kind of your experience in transitioning between academia and the industry, and are there some advice that you would want to give to the audience about what kind of skills should you be looking for and what kind of people you should talk to, et cetera, things like that? Yeah.
Sure. One of the best pieces of advice I got when going from academia to industry was make a technical resume. So this is a very specific piece of advice I'm passing along. So one of the big disadvantages coming from academia to industry are that you don't have the job experience. Your job title is graduate student researcher, TA. So as you look for selling yourself to industry, you want to focus on your skills. And so organize your skills because, like you mentioned, our careers have taken way different paths than what we worked on. And so you want to market yourself as being able to, I would say 4 areas. So innovation, problem solving, communication, leadership, and execution. And those are 4 skills that'll bring you success in any career you go into, whether you even move out of research into manager role sort of thing. And in everyone's PhD, if you go through a PhD program or a master's program and you're doing a project, you're going to gain those 4 skills in different ways. So learn how to market yourself and build those 4 skills. In particular, problem solving and communication are ones that I highly recommend that you emphasize. Everyone writes papers, gives conference talks, PowerPoints. That's a skill that will take you far. And then just being able to take problems as they come to you and solve them. And that will open many, many more doors than specifically saying, I have 4,000 hours experience on a Hitachi, so-and-so SEM, sort of thing.
Well, I can tell you how to change fields, which is, because I did it a bunch of times. And the way you do it, to be honest, is you just change fields. But really the way you do it is you have to have one foot in the camp that you already know about. But you need to start going to meetings and you read papers and you start talking to people, because that's where I'm a big fan of going to meetings and conferences, because you can publish all you want, but the people that you're going to meet and interact with and establish programs with and collaborations with, you're going to meet on somewhere at a meeting. And it really just comes down to that. You just put yourself out. And I never took a class in biology or medicine. I probably still haven't. So I know enough to be dangerous. But that's how I made the transition and work in the biomedical field. Is I just started reading papers, and you go to meetings, introduce yourself, and you have a significant technical background. You come up to people and you say, I did this, this, and this, and this, and so there's a hook for you for people to respond to you. But you do walk in with assets that people will respond to you, and you have to be pretty aggressive about it. I will say that if you're shy, it's going to be a struggle. But it worked out for me well at JPL, because JPL is pretty well known, and it's not just for its planetary stuff, but as a technology innovation site. So people would call me back. And people were willing to talk to me, they see my name badge. But I think if you come out of here with a graduate degree from here, that you still have that same ability for people to want to talk to. But if you want to do something that's different, or something that pivots away from the specific topic and you're interested in something else, you just have to really show up and talk to people.
Yeah, always be looking for those opportunities. The first job I got, I was having a struggle looking for my first job out of UCLA. And I actually found my first company by going down the sign-in list in the Nano Lab of industry users that were using the SEM. Keep bringing up the SEM, and I just reached out to a bunch of them, and eventually one stuck. So just look for opportunities, think outside the box.
I mean, I had a slightly different trajectory. I'm also not actually in industry. I'm more academia adjacent at the Caltech campus and the work with JPL missions. But for me, part of, I think, there wasn't a career trajectory that I was on or even imagined existed that would end me up where I am now into pretty much my dream job, honestly. But what I did was, I had a lot of hobbies when I was in grad school, and photography and computer graphics. One of the ways I'd keep myself sane in grad school was I'd go home and read manuals on how to do 3D renderings and things like that. I know it sounds horribly geeky, but it was fun. And by just basically pursuing things that I found exciting and interesting, photography, later bringing in Photoshop and really trying to be good at this as a hobby, I was inadvertently developing my skill set that was going to give me the position I moved into now. So I mean, I think there's a lot to be said also for if you have interests that are parallel to or even outside of your core research strategy, develop those, give those time too, because sometimes just having that skill available when an opportunity presents itself is the difference between getting the position or not getting the position, or having the opportunity to pivot into something that you might not have expected. So.
Yeah, I want to add to these. My first job came sort of random because I know this lady and she worked in my committee. One of my committee members' lab, and she moved to this company, Imagine App, and then I just saw her one day here in CNSI, and she said, "Do you know anyone who's looking for this type of job?" And I was like, "Me." So that's how I got it. So
Dick Cheney, right?
Yeah. So
that's all helps.
Yeah. So I think my point is, yes, if you want to move out of what you're doing right now, there's still, like what Rob said, still it's not a completely different area. You have little steps in between. So you know this, and you move here a little bit, and so it's a gradual process. So like for my PhD, I did virus, I did sometimes nanoparticles, but now I don't do those at all. I do animal work, but there's still a bridge in between. And I think for me, the important thing is you do want to focus on what you're doing now and perfect that skill, because you're gonna, all your connections right now is based on what you're doing now. And you can bridge from there, but you do want to have a really well-developed skill set as a start point.
And to echo one of Scott's initial points is that skills and communications, I think, will do you well across the board, whatever you're doing. And just the experiences I had in grad school, TAing classes, and actually after I got my degree here, I actually had an opportunity to come in as a lecturer for a few years and teach courses. That actually built up a skill set in public communications and education that I use daily now. It may be, there's nothing in my past that I'm specifically doing now. I'm not doing active research in radio astronomy or infrared astronomy, but the fact that I can speak the language of science, I can talk to researchers who are doing kinds of research that I never touched on in my research career, that still gives me the ability to talk to them, to understand the results, and then help translate that both in words and in images when we're doing science communication. So, I mean, there's a lot of things, a lot of skills you pick up in the PhD process that are incredibly powerful afterwards.
Yeah, I mean, you asked about how we got where we are, and I think the answer is that all of us can say, as you said, well, this happened or that happened. But if you'd come to me 30 years ago and said, oh, I want to be where I am now, how am I going to get there? I probably couldn't have told you. But I can look backward retrospectively. But what I can tell you is, what all the panelists have said is that you have to have a certain skill set, but also you have to be out there looking and say, I want to do a change, and be willing to talk to people and to make ideas and suggestions about how to begin to move a little bit in that direction. So, again, I started out in atomic physics, and, I haven't seen it in the rearview mirror for 45 years. And it's a surprise to me that it turned out the way it did, I'll tell you that.
Yeah, probably one of the only actual strategic decisions I made in my life that sort of landed me in this particular career path is that after I'd done my first postdoc, and I'd really come to the conclusion there that I didn't want to go the traditional academia route. I was actually really like soul searching. What was I going to do? I had a bunch of postdoc job listings were out there, and I was just unmotivated by any of them. But I remembered that IPAC was an institute on the Caltech campus that had a lot of support science going on, and that actually appealed to me. So at some point, a postdoc popped up at IPAC with one of the researchers there, and I know this sounds completely insane, but after my first postdoc, I applied for one postdoctoral position for my second. I had no passion for any of the others, so I put like 212% of what I was doing applying for that position into that particular job, and I managed to land that. But at the conclusion of that was an NRC fellowship. The weird thing was the person I was working with didn't even get to choose me. It was an NRC fellowship, so NRC was making the pick, but she wanted me to come, so it all worked out. But it put me in a place where I then had a couple of years to establish a reputation, and so at the end of it, when that was wrapping up, I sort of knocked on a door and said, hey, I was hoping I might be able to move on to a position. They said, oh, we were already talking about you. How about working on the 2-micron all-sky survey? We need QA scientists. So, at least by putting, if you see that there are places that do the kind of work that you might want to move into, right, do what you can to get in them or near them or be in touch with people, right? Because that kind of personal contact will be the thing you can leverage forward.
Okay, great. Yeah, kind of following along the line of the responses that you've given, it seems like networking is very important, regardless of what you want to do after. So do you guys have any suggestions about how to efficiently network and find the people that you want to talk to? Because I think graduate students and postdocs are very busy with their everyday work and trying to satisfy their professors. So kind of how do you pick and choose and where to look for the best kind of interest, or kind of how would you find people that you really want to talk to and want to learn more about?
Honestly, I am constantly surprised by where connections get made. And, just on the panel, we found some, small world kind of connections just a few minutes ago. And really just talk to everyone. You never know where those opportunities will pop up if you're walking in the lobby and meet someone, I'm not great at networking, but take those opportunities where you can. As a grad student, conferences are a great place. Vendors and salespeople who are always at these conferences too, trying to sell you their things. They're great at networking. And they know a lot of people, and I found interesting connections through people I already know through vendors, and keeping up touch with that. Yeah, they want to sell you their new microscope or their new vacuum pump or what have you, but they're also very good connections to know because they're in touch with the industry on a whole.
To me, I think don't underestimate your lab mates or your classmates in grad school, and also keep track of where they are, and if they're at a new company or they have a new position, then they might be your bridge person.
Yeah, I repeat my earlier advice, which is that I think the best venue is conferences, as Scott said. I mean, it requires you to go, and I know you need support money to get there, and I understand the issues involved, but I mean that's really where you get an opportunity to meet the people that you want to meet that are presenting. You ask them questions, you come up and talk to them afterwards, you see them at coffee. There's really lots of venues for meeting people in person. And I mean, there's a lot of people that I have have had contact with for years, and we've never met. And finally we do meet. And that always changes the character of the association, I think. You can meet people through email by asking questions about their papers, or again, people like to help. I think people underestimate this. That's one of the values of, that's one of the reasons LinkedIn works, by the way, is that people want to be helpful. And so if you email somebody and ask them a very specific question, you'll get an answer. And you can always find their emails, through their links on their papers. But I think you do have to build up a network, because eventually you'll be at a point where if you have a problem, you will not think of what do you know, you think of who do you know. And you really want to be there, because that's how you can get things done, but also how you can begin to move out of and into what you're currently doing into something which is, begin to pivot away from that. And it takes a lot of work. I'm not going to deny that.
I mean, coming back to the idea of just people in your lab, colleagues, a lot of my portfolio ended up being just work that I did to help friends out at IPAC who, say, had a press release coming up and they had no graphics being developed. And I said, hey, I do this for fun. Let me help you out with that. And over the course of doing this, and I had some of the animations I did appear in NASA television as part of official press releases. I was inadvertently networking with people at higher echelons in the administration who had noticed, oh, he has this skill set and it's valuable. So that I feel guilty sometimes listening particularly to networking jobs and how people stumble. The fact that my current job was actually created and handed to me. Someone basically said, hey, why don't you come do this for us? But the trick was, by doing what I was enjoying and setting myself up as having that skill set, that was part of a networking. It was a subconscious networking, but it was still a kind of networking.
Okay, great. So now to change the direction a little bit, since most of the audience here probably don't have that much exposure to the world outside of academia, would you guys share kind of your experience or compare between your life in academia versus the life in the industry, kind of what the benefits and the disadvantages, et cetera?
Yeah, sure. I will say that, so I went to traditional route, right? I got a Ph.D. and I was a postdoc, and I was another postdoc, and then I was looking for an academic position. So this is in the late 70s, when, to be honest, the physics market had taken a giant nosedive, and there really wasn't a lot of opportunity. And I will say that the best thing that ever happened to me was I did not get an academic position. In hindsight, it was terrific, because I wound up going to JPL, and there are a couple of features of it. One is that, it paid a whole lot better than an academic position did. And the other thing is that I found myself in a place which was just, really geared for the kind of stuff I was interested in doing, which was, building stuff and working in a lab and doing new technologies. And, JPL is one of these places where if you have a problem, there's a guy 2 doors down who is the world expert on cameras, sensors, CCDs, thermal analysis, whatever. So you can always, it was easy to do the kind of stuff that I was interested in doing. JPL, it's a little hard to explain how it works, but it's totally soft money. You have to support yourself. There's no job for you except for the job you create, right? For you understand how that works. Mm-hmm. And so at my level, where I'm a principal investigator and a PhD, I had to bring in my own money. And so I had the academic side of grant writing and begging for money and all that kind of stuff, which frankly, I didn't have to do as much as if I were a faculty member at the university, but there was still enough of it. But while I was there, I was consulting and working with outside companies. I said I started a few while I was at JPL, and a few more since I left. And it is a different world in the sense that I think in the business world, financial decisions on whether or not to go ahead with the project are faster. And if it's going to be no, you know right away. If it's going to be yes, it might take a little bit longer because it involves spending money. But the cycle for having new ideas and being able to try them out and is in general faster, unless you have a really big lab. If you're a big academic, like some of my colleagues at Caltech or USC, and you got 30, 40 postdocs, I mean, you can try anything. But that's burning up what you guys are currently doing. But But I think that the working for companies, as I have, is also starting companies. It's a different mindset in the sense that there's more deliverables on the line. You're trying to make something or do something, and you're using other people's money, and really this is other people's money. It isn't taxpayer money, it's someone else's money. And if you're an academic, your product is papers. I mean, that's what you do. Your goal is to advance knowledge and publish papers, and if you are a company, you have a different set. And so I do a lot of work in imaging and cultural heritage. So I've worked on texts at the British Library, I've worked at the Huntington, I've worked at the Israel Antiquities Authorities and Dead Sea Scrolls. And so people my colleagues that work with in that, our goal has been to try to make tools that people can use. It's a very underfunded area of work. So the goal there is kind of business-like, where you want to, my academic friends, they want to do published papers, but I want us to write software to put out as open source that people can use. So there are pluses and minuses, but it is a different world. I mean, it really is. I mean, the funding structure and the goals of being an academic are vastly different from once you step outside of that.
Yeah, I think you really hit the nail on the head with the the funding structure and what you can or can't do being very different. I mean, there's a bunch of different companies, all have different cultures, different ways of operating, but I spent 4 years as part of the Boeing machine. And you work on multiple projects, you have to record your time spent on each project down to the half hour, because project A might be funded by the Air Force, project B might be internal R&D, and that all has to be accounted. And and then you have to work within the functional buildup of the company. There's a purchasing department and a lot of stuff that does happen in academia, but in general we're shielded from while researching. Like, let's say you want to go order some screws from McMaster. Well, at Boeing that took 3 weeks. Whereas McMaster's down the street. If I did it at UCLA, I would get it. If I ordered by noon, I would get it by 4 p.m. So it's very different, what you're allowed to work on, what you're allowed to do. But also the tasks, they would, when I was at Boeing, they would bring me into all sorts of different tasks. So I wasn't just doing research, I'm also supporting production at times, which is very different than a research thing. You're looking for problems in the production line, you're doing a root cause analysis. And then I transitioned to Strobe. Now I'm at Strobe, which is a 5-person company. We're a startup, we're new, and I'm wearing lots of different hats. It feels a lot more like academia, but I'm also a little bit of a people manager, a little bit of a systems engineer, a little bit of got to go to the VCs and pitch my ideas to get funding, even do graphic design from time to time. And depending on the size of the company and the culture of the company, you could be wearing a lot of different hats and in a lot of different ways that in academia, where you're kind of focused on the one project, you kind of get exposed to a more variety of tasks in day-to-day life. So that's really coming back to it, why problem-solving skills and communication will really help you a lot, because the problems that show up aren't just of the scientific nature, but it's also, what do I do if I can't get a screw for 3 weeks? On the bright side, in addition to better pay, you also can go home at 5 p.m., depending on the company.
Yeah.
Working in media relations and tied to press release schedules, I think one of the earlier comments that probably is the most different for me is the deadlines, right? Because when you're working on a paper, you take the time to do it right, to get it finished. It'll expand to fill whatever period of time it needs to go. But when a paper is going to press in Nature, you have 10 a.m. on that Wednesday, that's when the press release goes out. So everything has to be all lined up and done on a very rigorous schedule. So, sometimes it turns out working on deadlines can be very, very inspirational. but it can also be frustrating too when you feel like, oh no, we really wanted to get this, like you wanted to do a little more. Sometimes you have to be able to step back and recognize, have you gotten to where you need to be? Can you call it done? And then can you just move on past to the next deadline? So that's actually, that's an interesting stress we sometimes run into after having done this for over a decade myself now. You know, we have a good sense with the media department on triaging. When have we reached our communication goals? But sometimes working with researchers, they want to keep modifying and tweaking, and it's like, well, you realize, you know, we have a hard deadline, right? And so sometimes it's kind of working with them to help them understand, like, yeah, this is a very different deadline structure than you're used to working with in academia.
Right, I want to add to that. In biotech biology, in the lab, you can, when you do research, you found a very interesting question, you can just pursue it however you want, basically, if the PI is okay with it. But in a biotech company, yeah, you identify a problem, you focus more on the solution. Say one formulation doesn't work, cause the animals to lose body weight, then you want to find one that doesn't cause it, instead of looking for what is the reason that they're losing weight. And also in terms of deadlines, because when you're at a biotech, there are many projects going in parallel, and the priority of a single project can be moved up or down at any time. So really keep that communication going and strong, because you think you're working on this project, it's very important, but then maybe another department may think, oh, now we need to deprioritize that one. And a lot of times I think communication is very important, because the other party, they probably won't read your email that carefully, so you do want to go that extra mile and say, we're going to do this, and just to make sure, we're going to do option B. So just confirm and double confirm. Make sure they understand it completely. Anticipate where they might miss it, and then stress that point once again.
I'm also going to add, this has been a bit of a tangent maybe, and I can't really speak from experience, having never not stayed in academia, but what I've observed from, you know, my PhD advisor is that even if you stay in academia, you know, as you're taking that upward path to professorship and so forth, you are driven by a lot of the same constraints in industry as well. You know, when you're a professor, you are a people manager. You're selling your ideas to the NSF. And so that also takes you out of the lab. And so there are some parallels there. And so that's one thing to keep in mind if you do want to pursue an academia path and stay in research. You know, you need to think about what that means and to how you want to stay in academia as well, you know, as a postdoc or a researcher, or if you want to go the faculty route, because you know, as you become more, you know, with the ability to do what you want comes the responsibility to make sure it happens. So you have to get the staff, you have to get the money, and that's true of academia or industry. So.
Okay, great, thank you. So taking another turn in direction. So because we have such, yeah.
I have a question. Am I allowed to ask questions?
Go ahead.
Both Scott and Greg brought this up about the pay being different between academia and industry. How do you, or I know this is a personal question, but like, what is the difference? The zero that we make and then the non-zero that you guys make, and also what is, how should someone that's going to graduate know their value that wants to go to industry, and how should you ask for a certain amount from the company, I guess?
Well, I have less experience with for-profit. I can tell you what the JPL pay structure is. I was a group supervisor for many years. So when I left the lab, which is in 2008, I had guys in my group who had PhDs, and they were lab guys. In other words, they were world-class physicists, and they were earning 140, 150 a year. And right now, I think so. If a new hire at JPL, brand new PhD, no postdoc experience, out of graduate school, they were going to bring him in certainly at 110, 120 easy. Startup culture is different. Startup in Pasadena I was associated with, we had somebody that was very hands-on, terrific lab guy. He was ABD, all but dissertation, and he was earning a little over 6. So the pay scale, the differences can be significant. I have no idea universities pay, but I when I was looking, boy, it was nothing.
Yeah. Thankfully, we have a lot of information available on the internet. You can look up,
Yeah.
Staff scientist and this much experience. It's hard when you are coming out of academia into industry because you don't have the industry experience. For example, I entered at Boeing at a level 4. So bigger companies, just like the government and JPL, have set levels where you have to meet certain criteria to move between. And within those levels, there will be a range defined. Smaller companies have a lot more fluidity, but so I came into Boeing at a 4, and the range for a 4 was X dollars to Y dollars, and then it's up to you to negotiate within that. I did not. I basically was using internet knowledge of the.
Yeah, but you can find someone that does.
Yeah. But like you can't go from I was a staff engineer, can't go to senior staff engineer until you have at least 3 years of experience as a staff engineer, sort of thing.
I think for bio, a fresh PhD, or after a few years, less than 3 to 5 years of postdoc, the salary range is 70 to 90. For like in here, LA. In San Diego and in NorCal, that would be much higher.
Okay, so we will have a 30-minute Q&A after at 10. So if you have any questions, we could save it till then. Yeah, so another question that I think the audience may be interested in is, because you guys work in very diverse fields, kind of what do you see is the future of imaging for the next few years in your respective fields? And is it a good job market by the time that these people graduate and look for jobs, or is it going to be better to stay in academia kind of thing? Yeah.
No.
Okay, I'll go for biology because you guys are.
But
I think for imaging, unless you're doing like the instrument, you're working on, say, MRI machine or something, then I don't know about that part. But as a biologist, I don't think imaging itself it's an anchor for a job. You have the skill, it's great. If they want to do imaging experiment, then they hire you, but that's not the only reason. You're gonna have the rest of the skill set as a biologist. So
I'd say software. I'm working towards self-driving cars, and the big problem there is teaching a car to see like a human and then better than a human. And I'm in LiDAR in particular, but there's so much going on with just camera imaging with what Tesla's done with autopilot. And I could spend the whole hour just naming companies that are doing AI for cars. And then you start thinking about what else needs AI. And I spent a lot of time at Spectra Lab trying to teach a camera to see when cracks are in a solar cell. And there's going to be a lot of applications for teaching computer vision, and that applies to microscopy as well as LiDAR as well as RGB imaging. I think like Karen said, the microscope is the tool, but then what you do with that is the future.
Yeah, I think there is a lot of potential for imaging for the kind of stuff I do, because I think what's going to happen is that technology will push the ability to do spectral imaging and 3D and other kinds of image down into mobile platforms. And people will be using them at point of medical care. They'll be using them on plant floors. They'll be using it out in the agricultural field. And there's a whole host of so the two issues are developing imaging technologies and then developing what do you do with all that data. And Robert and I were talking about this before the meeting, which is that imaging tends to just spit out vast quantities of data. I mean, you really don't even know what to do with it all. And so there's two issues. One is that you need, how do you find it? How do you store it? How do you locate the image that you took 2 years ago that you really need right now? And then secondly, when you have these huge amounts of data, how do you process all this stuff to get the answers that you want? So yeah, it is software. But I think that as technology continues its exponential rise, that a lot of stuff that people used to, do in a lab very laboriously a year ago will in 3 years be on your cell phone or in a dedicated mobile platform that addresses a very specific user need. And I think there's a lot of opportunities there. I think once you move out of, once it's common and everybody uses it, it just changes the whole dimension.
So imaging in the service of communications, I have a slightly different kind of career skill set, I think, than others at the panel, because what I do sort of equal parts working with imaging data sets and taking things mapped from different parts of the spectrum, building sort of photo quality images out of that serve communication purposes. But the other half of what I do is actually pure artwork. It's illustration, it's science illustration. And that's actually, in a way, it does combine what I know about imaging and science imaging, but takes in like my background in the science and my interactions with the artists to try to come up with artwork that helps explain. I mean, if you guys ran across any of the news stories, say, of the TRAPPIST-1 system that NASA announced recently with 7 Earth-sized planets, my colleague and I, we split up the planets in there to do artist concepts to help illustrate ideas in the system, like why a tidally locked world has a very different character than a planet that orbits around its axis. But as far as the future is, I mean, my tools are equally things like Photoshop to help me build up ways of improving the look of the raw data as I create a stacked image, multi-spectral image out of it. But it's also 3D graphics software, it's illustration software, and there's a lot of cool stuff you can do on your iPad these days and your iPhone, stylus input. There's a lot of neat stuff, but part of that is just developing whatever skill sets that you want to be adept at and moving forward.
To piggyback on what Robert was just saying, when I was this kind of comes back to the earlier question about how do you market yourself, and I was taught in grad school that you read a paper by looking at the images first, and then deciding if you want to look at anything else in it.
I was told by my advisor, you make the images first, and then you write the rest of the paper, because she knew how much I hated writing. So that was how she got me to finish these things.
Yeah, same with me. So that visual communication, how you present your images, is a really, really useful tool. And also, a lot of the stuff with imaging, I was thinking about this, that we're doing with the 3D point clouds as we take LiDAR data. We were talking with someone who works at, I think, Activision. And I was like, oh yeah, we use that same stuff for Call of Duty. And so, there's a lot of the imaging in the video game industry too.
One thing I might comment is in research, especially in astronomy, a lot of people, when they build the graphics for their papers, they're using effectively the research tools. And honestly, in the field of astronomy, the research tools are really poor at imaging. The core apps that everyone does to align their images and create these reference graphics are, they're literally using brightness contrast algorithm stylings that were designed in the mid-'80s, and they have not actually adapted to curves adjustments or gamma adjustments, right? None of this is available. And so even back when I was in grad school, one of the things that I had started doing is realizing that your analysis software only takes you so far when it comes to creating a final image. And a lot of, what distinguished myself from my colleagues was just turning to high-end off-the-shelf software and realizing there are things like Photoshop that you can take what you get out of your research analysis tools, and then that can actually take you the extra 9 yards to really get to an image that distinguishes itself and really stands out and can maybe even communicate what you're trying to get across more effectively. So, I mean, particularly now, there's an explosion of commercial software for imaging, not just Photoshop, but very kind of niche things that exist out there. So there, if there's any tools that you can find out there that help you with the kind of design that you're trying to do, even if it's just taking a PostScript file that gets generated automatically, putting it into something that lets you clean up the lines and make them, really let you choose color palettes more effectively, or overlay with other images to build a multi-layered presentation of information, right? Any of this can really help up your game in image communication.
Okay, so I think we probably have time for one more question. So to make it more general, looking back at your career, are there any things that you would have done differently had you known what you know now about your past? Yeah.
No. Sorry. I've thought about that a lot. It's like,
That's great.
when you weren't aiming for something, it's you don't want to mess with it because it might screw up the whole process that landed you where you ended up.
Yeah, no, I think it was a bit of a stochastic random walk process, and I'm really happy the way it turned out.
That's great.
Same here, but I'll pass along a piece of advice I got from someone, which was don't become really good at something you hate. My career has been great, but I got good at doing budgets for proposals. And then I did every budget for every proposal then on. And so then when you go to the new job, don't tell them that you know how to do that.
Okay. Karen, do you have any?
Oh, no, I have no regrets for
Okay.
anything.
That's great.
So just don't make any bad choices,
Right.
and then you'll be happy with your career.
Can't go wrong. Can't go wrong.
Yeah, and also, you can't go back and correct anything, so this is where life takes you, so it's perfect.
Yeah.
Okay, great. So I guess at this time, I'll open it up for questions from the audience, if you guys have any. Yeah.
So you all seem pretty happy where you are in industry. Is there anything about academia that you do miss, like maybe the pacing or the freedom?
Yeah, I liked having grad students. And because you can get a lot done. I mean, it's a fun process, and I mean, you really have someone that is really doing a lot of very detailed technical work and turning knobs, and but they have great ideas. But I mean, I got out. I did a lot of cultural heritage imaging for a long time, and I sort of got out of it. I worked with Northwestern University for a few years on some new ways for doing measuring surface shapes and surface topography of paintings and sculptures and basically cultural heritage objects. And we kind of ran out of. I mean, the grad students did like really phenomenal work, and they really made it work. The project, but I mean, I left it because that project kind of died. And I realized that. Absent students, for example, I wasn't going to make the kind of progress I wanted. So yeah, I think from when I was at JPI, I was on students' committees at various universities. So I had students that work in my lab part-time and use our equipment and our technology. So I did have students while I was there, but they weren't mine, if you know what I mean. They would. But I do miss that part. That's really about it, I think.
I mean, being kind of academia adjacent, like I say, I think I have a little more flexibility. I still have some of the perks of academia, a little bit more opportunity to do sort of self-motivated projects I specifically want to work on. But I think there's probably an anti-correlation to how much you get to follow your own direction and how much they're paying you. The bigger the paycheck that comes from industry, the more that someone else is going to be telling you what to focus on to invest that. So that might be a consideration, honestly, of quality of life, of how big do you need a paycheck to be, how much flexibility do you want. So.
Yeah, I think what Greg said reminds me of this one lady. She used to work at the Buck Institute, and she's part-time at UCLA right now. And she just she's moving to our company, but what she has, she's a professor, so what she has in her mind so she has a few drugs for Alzheimer's and they're her babies. And what she has in mind for the experiment setup, she can only achieve that in an academic lab. She wants a behavioral test for 8 hours. She wants a postdoc or a grad student to watch the mouse swim for 8 hours. But in a company, you're not going to get that, because also when you're in grad school or when you're a postdoc, you're younger. You don't have family responsibilities. But now you get married, you have kids, you have a lot more, not just in your career, but everything else. So if you want to stay in academia because you're interested in your project or you have a very specific idea, then professorship, it's a better way to go. In a company, it's more corporate. Someone will tell you what to do instead of driving your own project.
I miss having not as many meetings every week. But in addition to that, so, when I got into academia, when I went to grad school, and I think at least a little bit of every grad student maybe shares this, is academia has this culture of being open and sharing. Like, you're doing something for knowledge's sake, and you want to share it with the world. Whereas when you're in industry, IP, you're dealing with IP, and you can't share things. And that's the nature of the business. That's how you make the money. So there's a very clear culture shift. So, some people aren't ever fully at peace. I've had coworkers who were never at peace with that kind of mentality, and ended up actually going back into academia eventually. So I miss that a little bit. They're a bit of my, bright-eyed, want to share what I'm doing with the world as opposed to just sharing the end product. But I don't regret it either.
Okay. Any other questions you may have? Yeah.
How hard is it to, be a part of a startup company as well as starting a startup company?
Okay. Just to reiterate the questions for people who are watching online, the question is it hard? How hard is it to start a company and being a part of a startup company?
We need a good idea. It really depends. So my group at JPL had ideas for spectral imaging. So we started a company, my colleagues and I, and we got to a certain point, and we had a big commercial partner, and it kind of fell apart after about 3 or 4 years because of lack of execution. The mechanics are dirt simple. They really are. Starting a company you can do online in 10 minutes in the state of California. But the other parts are you really have to put you have to put a lot of time into it. And when we started this particular one, my wife and I had enough assets that we funded it ourselves. And we not enough to jeopardize my retirement, but it was enough money that it would hurt if we lost it. So it's the answer is mechanically it's easy, but you really have to. Here's the hardest thing I think about, particularly the people that do technology, is you have a great idea and you say, wow, this is really slow. Everybody'd want one of these. Who wouldn't want one of these things? And the answer mostly is no one. And so and this is particularly true for people like me who, I'm basically a physicist and an optics and imaging guy, but I work in biomedicine. So you say, and this has happened a lot, where people will say, oh, I got this great idea and it solves this problem. And you go to talk to people that work with it all the time, and they say, well, we don't really care about that. You solved a problem that we're not interested in. So I would not call it market research, but if you think you have some technology or something that you've worked on that could be a product, the thing to really make sure is that your enthusiasm for it isn't misguided. It's like, if somebody once asked me about my technology and whether it works. And I said, well, that's like asking me, are my grandchildren cute? Well, of course they are. Of course this is the world's greatest technology idea, but it just may not be.
Essential to having a successful startup is having the right team too. In a startup, you're very small, 3, 4, 5 people, and if you don't get along and you're clashing at every step of the way, you're not going to make it. It's not going to be pleasant for anyone to work there, and no one's going to want to invest. And especially if you're also looking for investment, the team has to have the right amount of experience too. In my limited experience with VCs, they're less vetting the technology as much as they're vetting the team. And they're making sure, oh, you have a CFO who's not going to go to Vegas and put all the money on roulette or something crazy. They want to see, the more, my CEO has done other companies. This is her 4th company that she's been the CEO of. And so that has taken us a long way just in.
Yeah, Julie knows her stuff.
Yeah, Julie's great, and they're because VCs and the people who are giving money, and maybe you watch Shark Tank, you're not coming to Shark Tank to tell experts who already know about your great new umbrella or whatever. They're not umbrella experts, but they want to make sure that the business has a chances of succeeding, has the right leadership. They can go find people who know something about umbrellas and ask them the questions. But they want to invest in you when you're at a startup. So you really need that, charisma, communication goes a long way there too, and pretty pictures.
Yeah, I would really echo that. So, I not only have I done a few companies, but I've worked for a number of small companies as chief scientist or CTO. So I've seen what goes on. And my wife, for a number of years, used to provide business services to startups in Pasadena. And most small companies that are startups that fail, they don't fail because they got a crappy idea. They fail because they can't get along, or the founders hate each other, or the board starts fighting, or a member of the board starts shoveling money to his ne'er-do-well brother-in-law who's a lawyer to do their legal work at inflated prices. I'm bringing up real-life incidents here. And so, and Scott's absolutely right. My first comment about technology is certainly, I think, the key part, but the companies that I've seen fail, it wasn't because it didn't work. It was because it fell apart on a personal level.
So along the same line as this question, what do you recommend as kind of the time point at which you really plunge into a startup? So is it when you have a good idea that you think will work, or is it when you have a team that you think will make any product succeed, or is it some other factor that helps you decide?
Just from my personal kind of experience, I was brought in pretty early on, and it was early on where nothing had been built yet, but late enough that there was some funding, some seed funding. So I was personally comfortable only when the technology was right, because you could also have a great team, and if you have no new idea, your startup will fail as well. So the technology was right. I was reached out by Lute and Julie, my CEO, and they were looking for someone to come on. But there was also the kind of the security, safety blanket of knowing that, hey, I could be paid for the next year at least.
It's important.
But yeah, you want to make sure you can pay rent. So. You kind of have to judge your own personal, what risk are you comfortable with. If you're early on, the earlier on you are, the more risk you're taking on. And if you can support yourself or have a high level of confidence that you're comfortable taking that risk, jump in early. If not, wait till they get a Series A funding if you want a little lower risk, where they've built the team up to 10 or more people, but maybe you're not getting stock options at that point anymore, but you have a lot more confidence that they'll make it past the 5-year the gap and be successful.
Okay. Any other questions from the audience? Be interested in? Yeah.
Sure. You mentioned earlier that you think one of the next big things or the big thing to bring to the table in imaging is software. And I think it was Scott who mentioned specifically things like computer vision and machine learning. Are there other types, specific things in software that you see as being really important to industry jobs in imaging? And just regardless of that fact, what's the best advice to someone who's relatively new to creating software to get up to speed and to get into computer vision or machine learning or anything else that's going to be new and important or is important now?
So the question is, what are some important aspects of the software that will be important for industry jobs in the coming years for imaging or any kind of tech-related jobs, I guess? Yeah.
As opposed, or in regards to the, in addition to machine learning, what else is there? I'm not super familiar, but I think, in general, it's kind of like pattern recognition and deconvolution and are just the sort of algorithms that I've been exposed to as being needed. And maybe my panel members can help on how that applies to biology and what's needed. But advice as to someone who is not too familiar with software, there's lots of different software out there, and all it is different shells for the algorithms. So I would look into what the algorithms are, learn, when I say machine learning, what does that mean? There's lots of different ways to pattern match. You could do 1D pattern matching, kernel convolutions. Just try to look into that technology, and then when you're on the job, you might learn LabVIEW or C or Java or Perl or any number of languages that are out there has a specific syntax, but the core concepts of what the software need to do are something that to be focused on. I hope that made sense.
Okay. Other questions? Okay. Guess, yeah.
If nobody's got another question. PhDs obviously take a really long time. Are you guys at all bummed out or anything like that about not working on the same stuff that you're interested in grad school now? I guess.
So the question is, are the panelists disappointed that they're not working on their thesis project anymore after grad school?
No, not in the slightest. Well, look, I mean, it's often common. I actually wanted to be an astrophysicist, and I wound up getting and working with the guy I did for my PhD because the radio astronomer I wanted to work with didn't have any money at the time, so he couldn't have supported a graduate student. And so I think the answer is no. I mean, I got a degree and I learned how to do a certain set of skills and how to think about things in a certain way, and I built my career on that. I mean, I couldn't make a living measuring the fine structure constant. I mean, that's just not going to work.
I mean, while I'm not doing any of the specific core research I was doing in grad school, what's actually fun about what I get to do is I get to learn about the whole breadth of results coming in from astrophysics, and in all the ways, esoteric as LIGO. We were involved with the big LIGO press releases. So what I learned in my core specialization has given me the language to really now sort of understand the broad breadth of what's going on. In some ways, I think that's actually kind of more fun for me because it's actually neat getting the much bigger picture of what's coming out of NASA, what's coming out of Caltech. So.
Yeah, and in grad school, you're not just doing the research, not just the stuff. You're learning how to think and how to criticize, how to think independently. So you're going to apply that your entire life. So no regret.
How to read a paper, even if it's not in your field.
Look at the images.
Exactly. You start there. And the captions.
Personally speaking, I get bored of something after 3 to 4 years, and unfortunately, my PhD took 7. But one of the nice things. So no, I don't miss what I was doing in my PhD. But at the same time, a big trend for the last 30 or so years is that industry has been moving to more project-based structures than functional-based, which means that you work on projects less so than you kind of do the same thing all the time. So within even within one job, you get the opportunity to work on multiple projects, and so that's where you pick up these new skills, where you pick up the opportunity to try something a little different and get your foot in the door, and maybe segue that into the next job or the next position at the same company, or to really expand your breadth.
Yeah, I think that, for a more serious answer for me is that a lot of what I did while I was at JPL, I didn't specifically use skills from having a PhD in physics, but you couldn't have done the job without having a PhD in physics, regardless of what it was. In other words, you needed to have those experiences in order to do it, even if you weren't specifically doing physics-y type stuff you did as a PhD. It wasn't going to work.
Yeah, a thesis is really a proof of concept that you can tackle a project beginning to end and work through it. It doesn't have to be that that specific topic really inside out. I think it's much more, especially in industry, people are looking at people who can be handed something and go through that process and come to conclusions. So it's a powerful tool, but it doesn't have to be that focused on where you were in grad school.
Along that same line, are there any non-science activities that you guys have done that helped you guys gain experience outside of a lab towards what you're doing now?
Improv comedy. I will be proselytizing here, but I've done like 5 or 6 years of improv comedy at Upright Citizens Brigade. I think Improv 101 is a great skill for anyone to have, because it teaches you to get on a stage and to make stuff up, and that is what all conversations are. When you're networking, when you're in front of a boardroom, you can't plan on what you're going to say.
Poor choice of words.
Yeah. Exactly. And just it removed a lot of the fear I had about speaking to people, and I would not be where I am today if I weren't able to speak to people.
I was painting, I was airbrushing pictures of galaxies and nebulae when I was in high school with a more or less tolerant art teacher who did that. The art came with me. I also ran the sci-fi club here at UCLA for a long time, and actually trying to manage a large group of scattered geeks all over the place, that actually gave me significant skills for working with large groups of people, pulling in lots of different directions. So, yay Enigma! Anyone here in Enigma? No, I want this. It's still here, so yay.
Okay. Question.
I have a question related to that. So how do you, so like when you're doing a resume or like you're in an interview, how do you bring in something that's not even remotely related to your research, but like you get leadership skills, you get communication skills from it? That's just like extracurricular activity you might do a lot.
Okay. So the question is, how do you incorporate extracurricular activities into resumes that will help you look like a more complete applicant?
I'd say that maybe works better for an interview than a resume itself. Although, anecdotally, the woman who left the job that I ended up filling had on her resume, had native Texan on her resume, and that kept getting brought up to me. It's like, oh, when Diane interviewed, she had native Texan on her resume. But so it can help you stand out if you have something like that. But the resume is kind of a gateway to saying, this person has enough of a background to be that we're confident enough that we bring them in for an interview. And then when you have an interview, there are a number of questions that you can probably expect, and I would recommend having, prefab answers for them, which can go into your extracurriculars. But they're going to be like, tell me a time that you had to ask for help. Tell me a time that you helped someone on a different project. Tell me a time that you had a problem that you had to overcome. There are these sort of generic that are kind of questions that dig at that sort of thing. And it doesn't have to be, oh, when the microscope got stuck, I had to come get a wrench and bang on it. But you could say, let me tell you about this time when I was trying to organize a dodgeball tournament, and I had to deal with vendors and sponsors.
No, I haven't interviewed for a job in decades, but I've hired a lot of people. And what Scott said is right. When you have to be prepared to bring that up, though, if you do volunteer work, if you've had a significant role in communications, working with an organization or something like that, that's where you bring it up. If you have hobbies that you think are relevant, you do woodworking, for example, or you're a famous metal sculpturist and you can weld like crazy. So that's where you bring it up, but you have to have a canned answer, or you have to find a way to slip it into the conversation. But Scott's right. And I do the same thing. You ask people when I'm hiring somebody, I assume I'm not going to ask you technical questions because I figure you already know how to do that stuff. All right, and I've occasionally once found out that was not the case. But what you want to know is, what's this person like? What do they do when they're not just in the lab? Do I want to see this person for 8 hours a day, for 4 days, for 5 days a week, and do I want to have to figure out how to pay for them, by the way, also? So I think your job as an interviewee is don't sell your technical skills. Yeah, they're relevant and they're important. And if someone's hiring you to be able to do GFP transfections, well, you really ought to know how to do that, all right? But they're really interested in the stuff you asked about because they want to know if you're going to be fit into the team. And to be honest, frankly, you can always make a guess, but you never know until you hire somebody. And my younger child is a musician, and the way orchestras have started to hire people now is they come in for auditions, and they don't hire them. They bring them in to play for a week. So they get like a tryout period. And then after there's 2 finalists, then they make a decision based on those interactions over the week.
Yeah, and I say don't stress over an interview because the interview's purpose is really to see if you're a good fit for the company's culture. And if you're not, it's not like your fault or anything. It's just it's not a good fit. And you don't want to pretend that you are a good fit and later it turns out it's not. So just be your true self.
And don't forget that it's a two-way interview, right? It's determining if you're right for the company's culture, but you need to also be asking the questions to find out, is the company culture right for you? So,
Unless they're paying you a lot of money.
Well, yeah.
Well,
You can always cross benefit.
Yeah.
Yeah, you talked a bit about transitioning fields into something you've never done previously. When I think about that, I'm often intimidated by the fact that people have done their Ph.D. in a specific field. For example, if I'm wanting to go to imaging and I'm a plasma physicist, then I don't know, I'm going to be competing against these people that have studied that. So how do you get around that? Is it just you go for it, you talk to people and don't look back, or do you have any advice about that?
Okay, so the question is, how do you transition from what you did during your thesis to a field that's completely different after you graduate?
Yeah, I think I wasn't quite in that same boat. In other words, I had background in imaging and spectroscopy, and then I started, looking at applying this to biology and medicine, and then I started to move more. But I still think that it's possible. It might be a harder deal. And by the way, if you're moving into something which is new and interesting, there aren't going to be a lot of people that studied it in graduate school either, right? And I mean, when I started doing this, bioengineering was actually just getting kicked off. The Whitaker Foundation had not decided to spend down their hundreds of millions of dollars and create all these bioengineering centers, which is where a lot of this came from. And so we were all feeling our way around. So the fact that, that I think as all the panelists said is that, you have some specific technical skills, but if you have a PhD, you really ought to know how to pick a research project or pick something interesting and figure out what are the steps I need to do to solve this and to make progress on it and getting back to work. That's what you're being hired for. I mean, yeah, you're being hired because if you're thinking about because you know how to do certain things that they want you to do, but they also expect you to be figuring out how to do new stuff. And yeah, it's hard, it looks intimidating, but it's particularly difficult dealing with doctors because they have a different view of themselves than we do of them. Actually, I'll tell you this. So I have visiting appointments at a number of medical centers, and so if you go there and they give you a tag, it'll say Gregory Bearman, Ph.D. And if you have an MD, it'll say blah, 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 MD. Because they really want to make sure who the MDs are and who the PhDs are.
But something like imaging has so many applications across the fields of science and engineering. To whatever degree it's possible, you could always, if you're trying to plot a longer-term trajectory or open up additional skill sets, right? You could always try to focus on what aspects in your own, in plasma physics that might be imaging-oriented. I mean, at some basic level, you got to take pictures of some of the things that you're doing. You're trying to record this data. There may be elements of what's in your core study that you can bring in and become the guy in the lab who knows more about how to do the imaging the best way. And that can at least give you the beginnings of the skill sets that then you can take and say, hey, look, I've done this and I want to learn more about it, but this is where I got up to that point.
Yeah, and when they interview you, they know your background. So they know you're not the expert in the field, and they want to bring you in for an interview. So be confident that they like you. And for a lot of job postings, they cannot, like you said, they cannot find an expert in the field. So they're exploring, they're widening out their candidate. So tell them what you can do and what your capabilities are, not just the science, the stuff, but how you think and how you function in the team and how you communicate. And also, if I can ask, that brand new field, is it because it's a job posting, it's like because it's a job and it pays well, or is it something you're really interested in and you're thinking of going into? Because if it's just a job posting, it's sort of random and you don't have to get into that field. But if it's something you're interested in, then I think that's your edge, because I did this, but this fascinates me so much, and that gives you an advantage over other people.
I'll just add anecdotally that, say on the side of hiring people, I've had brought in people who fit the job description to a T and underperformed. And I've had people who don't match at all and have just exceeded all my expectations and excelled. And because they're able to translate what they already know into learning what they need to do and going and doing it. And, grad school is learning how to learn, sort of thing. Just being able to learn on the job and take what you know and apply it. And you just need to get your foot in the door and be able to say, hey, I have the minimum skills needed to take this and run with it. And for all the other X factors with how you work on the team and charisma and stuff, that is, so there's a reason why industry experience trumps academic experience, and that's because you've kind of already vetted it, right? So if you're applying, once you're already in industry, if you're trying to switch, I think it's easier versus someone who might be the world's expert in academia. When you're both at an academia level, it's all these X factors that come into play.
Okay, so I think we have time for one short question. If not, if you have individual questions, you could come up after the session. So let's thank all the panelists for being here today. All right, hopefully you guys got some answers, and good luck to you all in the future.